The stars are brightly shining. It is the night of our dear Savior's birth. Long lay the world in sin and error pining, till He appeared, and the soul felt its worth. A thrill of hope, the weary world rejoices, for yonder remains a new and glorious morn. Fall on your knees, oh, hear the angel voices, oh, night divine.
Jason has a cylindrical pitcher in which he wants to pour the eggnog with. This pitcher has a radius of 2.5 inches and a height of 9.25 inches. Jason also has a cylindrical glass in which he fills the eggnog with that has a radius of 1.5 inches and a height of 6 inches. Seeing as both are cylinders, the radiuses will remain constant. However, let's remember that when finding the change in height in respect to time, the heights that we measured are not actually needed. First, Jason had to find the constant rate, or change in volume with respect to time, of the glass and pitcher. He did this by measuring the amount of eggnog that was poured from the pitcher, which was 180 milliliters, over a certain period of time, which was 5.2 seconds. This rate was then converted from milliliters per second into inches cubed per second to represent the change in volume in respect to time. The volume of the cylinder-shaped pitcher is going to be pi r squared times h. We also have to remember that the dV dt is going to be equal to negative 2.113 inches cubed per second, with the radius being 2.5 inches. With this radius being a constant, we can plug it back into the original equation, making volume equals pi 2.5 squared times h, and then finding the derivative of that equation. The derivative of this equation is going to be equal to dV over dt equals 6.25 pi dh dt. We already know what dV dt is, so we plug that back into the equation so that we can solve. Now the only variable that Jason has to solve for is the one that he needs to solve for. So dh dt, or the change in height with respect for time, is going to be equal to negative 0.18 inches per second. Jason is going to use the same equation for volume when solving this problem. However, his change in volume with respect for time is going to be positive 2.113 inches cubed per second. Jason's radius of the glass is 1.5 inches, which we know is a constant, so we can plug it back into the original equation to find the volume. We know that the next step is solving for the derivative, which is the change in volume with respect to time, equals 2.25 times pi times the change in height with respect to time. Since we already know what the change in volume with respect to time is, 2.113 inches cubed per second, we plug that back into the equation to solve for the only variable left, dh over dt, which is the variable that Jason is trying to find. dH dt ends up being 2.113 divided by 2.255. This turns out to equal 0.299 inches per second.